Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson on distributive property. If you notice, I already filled in some definitions to save some time, so you'll want to make sure you pause the video and get these definitions in. So distributive property hopefully is a little bit of review for you. Distributive property means when we are multiplying a number by a group of numbers, and we know that because the number is going to be right next to the parentheses. They're going to be touching, so we know that's multiplication. When we're doing that, and inside the parentheses is adding or subtracting together, then it's the same as taking that number outside the parentheses and multiplying them separately to each term inside the parentheses. So multiplying a number by a group of numbers that are added or subtracted together is the same as doing each multiplication separately. So for example, I'm going to zoom in here and try not to get into the way of that definition there. So the -6 we're going to distribute and do -6 times x, and then we're going to do plus -6 times 3. Now I try and simplify this right away, so -6 times x, we can just squeeze those together right away. That means -6 times x. Now I think of this negative times a positive and write it with one sign. So a negative times a positive is a negative, and then 6 times 3 is 18. So -6x minus 18. Okay, next one. Again, I'm going to try and show you how to do this so we have one sign rather than minus a positive or adding a negative. We want to simplify that to one sign. So here we're going to do -7 times 3x, and then we're also going to do -7 times, and then at the end of there, that 6 has a minus sign in front of it. So I'm going to call that a -6. Minus, negatives, they're the exact same thing. So -7 times 3 is -21, and then attach that x on there. Now here, a negative out front of the 7, negative in front of the 6, negative times negative is a positive. So I'm going to write it down as plus, and then 7 times 6 is 42. All right, that is simplified rather than writing minus -42. Okay? And last one, if there is no number in front of the parentheses, remember that there's always an invisible 1, so there's really a -1 out front here. So we're going to do -1 times 6m, and then we have a -1 times, again, there is a minus or negative in front of that 6. So if we simplify, we can write this as -6m, and then again, a negative times a negative switches to a positive, and then 1 times 6 is 6. So -6m plus 6. Sorry, that looks like almost a variable. All right, so that's the distributive property. Now we're going to talk about combining some like terms. So we're going to be using these terms quite a bit. The coefficient is the number that's in front of the variable. So for example, and I'm going to show you by color here. Let's highlight everything in orange for the coefficient. So the number in front of the variable, that's a coefficient. 6 is a coefficient, and then in front of this one there's a minus sign, so I'm going to underline all of that. A -3. There's a plus in front of that 6, so that'd be a +6. There's nothing in front of that 7, so that's a +7 as well. So those all represent our coefficients. Okay, variable, hopefully you guys know what that is. A variable is a letter in math that represents an unknown. Then we have a constant. So a constant is just a number and it has no variable. So for instance, this 6 at the end, and notice I'm circling the minus sign in front, that is what we call a constant. Okay, terms. So I'm going to use that word a lot as well. Terms are numbers and variables. It could be a combination of them. It could just be a number by itself. It could be a variable by itself. But they must be separated by a plus or minus sign to call them terms. So in this top, that example we just had, 7x squared, that is a term. Okay, 6x squared, that is a term. There's a plus sign in between there, so that tells us that's the separation between the terms. -3y is a term, and then -6 is a term. So there's 4 terms in that example up above here. Okay, now like terms our definition there, we need to have the same variable and the same exponent. The coefficient can be different. There we go, there's the different. So let's look at that same example we've been working with, and let's find some like terms. So for example, this 7x squared, I'm going to underline. This 6x squared has the same variable x, and it also has the same exponent 2. So those two are like terms. Now, this one over here, negative 3y, it's a different term. I did a different color. If you don't have different colors, I know with pencils, sometimes we double underline them, we box them, we triangle, but somehow we can show what are like terms, what are not like terms. And then the negative 6 doesn't have a variable on it, so that's our constant. So it can't be connected with anything else because everything else has a variable. So if we wanted to simplify this, 7 plus 6, we just add the coefficients. So we get 13. The x squared stays how it is, okay? The 3y, we can't combine it with anything. There's nothing else that is underlined in orange or double underlined. And same thing with the minus 6. So this is the furthest that we can go when we simplify, okay? So let's do some examples. If you would like to kind of challenge yourself here, I would pause the video and work out those 6 examples and then play it and see if you get the same answers as me. All right, so first example here, 7 times h, we can write as 7h. 7 times 5, everything is positive, so plus 35. All right, number 2, negative 6, we're distributing to positive 7, so we get negative 42. Then a negative 6 times, again, there's a minus in front of there, so a negative times a negative, it's going to switch to plus 42, and then don't forget that n. Now, to write this correctly, we're going to eventually talk about where the coefficient, the variable, always come first, and the constant always comes last. Now, the constant is negative 42, so we have to write that as minus 42. It's the same thing, but now it is written in our correct form. Okay, here's another example where we have a negative 1 out front. So negative times a negative is a positive. 1 times 4 is 4, so 4x. Then negative 1 times negative 6, so we get plus 6. And last one, don't let the fractions intimidate you. Think of 1/4 of 4, or we can write it out as 1/4 times 4 over 1. You're going to get 4 over 4 or 1 over 1. So we're going to get 1f. 1f is the exact same thing as just f. Okay? If we just have a variable by itself, there's really a 1 in front of there, but we don't have to write it. And then 1/4 of 8 is 2, so minus 2. Okay? So those are all examples of the distributive property. And let's take a look at these last ones. So we have like terms, all right? Like terms, they both have y squared on them. So we just work with the coefficients. Negative 4 plus 9 is positive 5. So we can simplify it to 5y squared. All right. When we write this in order, we always want to start with the highest exponent. So this positive 3h squared, I'm going to go to first, just because it has the highest exponent. Now, there's no other term that has h squared in it. So I'm going to switch colors and then show that negative 7h and negative 4h, they both have the variable h on them, and then they don't have an exponent. There's really an exponent of 1 on there. So those are like terms. And then lastly, our constant here doesn't have anything else we can combine with. So when we write this final answer, the 3h squared is going to stay exactly how it is because we can't combine it with anything. The negative 7, we're going to combine with the negative 4 because they both have h. So negative 7 plus negative 4 is negative 11, or you could think about negative 7 minus 4. It's going to be the same thing. And then that minus 3, our constant, still needs to be included on there. And that is simplified. That's the furthest we can go. We don't know what the variable h represents. Okay? Again, then, if we have multiple variables, so you see we have m and n, then we go in alphabetical order. So I'm going to go straight to the m. So negative 4m, there are no other terms with m, so I'm going to switch colors. We have a variable n. Down here is also an n. The exponents are 1, so those are like terms. Remember, the coefficients can be different. And then our constant is a plus 1 here. So if we simplify, like I said, coefficients, variables first in alphabetical order. So negative 4m, and I'm saying negative because there's a minus sign in front of it. The n's we can combine. Remember, an n by itself, down here at the end, there's really a 1 in front of there. So 2 minus 1 is 1. It's a positive 1, so I'm going to write it as plus. And I'm going to simplify it to n rather than 1n. And then we still have that constant of plus 1. So negative 4m plus n plus 1 is simplified as far as we can go. And last example here, we have multiple variables. So remember, they have to have the same variables on them. So let's look at AB. This one also has AB. This one also has AB. And this one also has AB. So all of these are like terms. They have the same variables, and then they have the same exponents on them. So all we have to do is work with the numbers. So negative 2 plus, remember there's a 1 in front of there, is negative 1. Negative 1 plus 9 is 8. And then 8 minus 3 is 5. So let's show negative 2 plus 1 is negative 1. And then we have plus 9 minus 3. So this is 8 minus 3, and this is where I get 5. And then don't forget to have those variables that they have in common, those like terms. So 5ab is what we can simplify it to.